Mr. Catlin back with you, lesson 6. I am trying to get through these quickly because I literally recorded all of them with no volume the first time. So this is my second time to do these videos. And I'm ready to go home. It's lesson 6, number 1. Let's go. Weather forecast says there's a 75% chance that it will rain later today. So let's draw a spinner that would show that. All right, 75%. That is a nice little multiple of 25. 25, 50, 75, 100. So I'm going to break it up into 1, 2, 3, 4 equal sections. My spinner. And this is 3 out of the 4. So I'm going to say that this one is going to be rain. This one's going to be rain. This one's going to be rain. But that last one, no rain. No rain on that fourth one because there's a 25% chance it's not going to rain later today. I have drawn my spinner. You're welcome. B, describe another way you could simulate this probability. Okay, a different way. Out of 4, something that has an out of 4 chance. I'm going deck of cards. All right, a deck of cards. So I draw from a deck of cards. All right, follow me? You follow me? I'm pulling out from the deck. And in a deck of cards, there are 4 suits: hearts, spades, clubs, and what's the other one? Hearts, spades, clubs, and diamonds. All right. So what I will say is, since it took me so long to come up with diamonds, that's going to be my no rain. So I'm going to say that the beautiful hearts, which that's a horrible heart, by the way, plus a spade. Oh, that's not good. Let's try that again. A spade. What am I doing? I drew the exact same thing. I can't draw a spade. All right. Spade's kind of like this, right? Wacha. There it is. A heart, a spade, or a clover, the club, right? We'll say that that equals rain, right? And then the one that I couldn't think of because I had a brain fart, the diamond, that's going to be no rain. If I pull one of those 3, it's raining. If I don't, it's not raining that afternoon. 75% chance because this is 3 out of 4, and 25% chance because that's 1 out of 4. How about them apples? Number 2, an experiment will produce 1 of 10 different outcomes. Okay, I'm following. With equal probability of each, 1 out of 10. Why would you use why would using read much? Why would using a standard number cube to simulate the experiment be a bad choice? Why is it bad to use a number cube with a 10 outcome event? Okay, so because number cubes only have 6 outcomes. There's not really any way to express a 6 outcome experiment with something that needs 10. So that would be the issue right there. Number 3, an ice cream shop offers 40 different flavors. To simulate the most commonly chosen flavor, you could write the name of each flavor on a piece of paper and put it in a bag. You could do that. Draw from the bag 100 times and see which flavor is chosen the most. Why is this simulation a bad way to figure out the most commonly chosen flavor? Oh, okay. This way that they've decided to do this, okay, every flavor has equal chance in this simulation, right? Every flavor has an equal chance to be drawn. But favorites usually don't work that way. Okay, when it comes to ice cream flavors, think about this. Ice cream flavors, people have favorites for a reason. Okay, there's more vanilla and chocolate in the stores for a reason because those are pretty popular flavors. All the other stuff is, like rare, not as popular. So there's not going to be as many of those options. And not every flavor should have an equal chance in this situation. This should be something, if you wanted to simulate it, you actually go and you look at an ice cream store at the end of the day, how much vanilla was taken, how much chocolate was taken, how much strawberry was taken, how much Neapolitan, Rocky Road, Chunky, whatever. you look at the results. That's not really a good one you can simulate with, randomness. Not a good choice. Number 4. There is a proportional relationship between a volume measured in cups and the same volume measured in tablespoons. 48 tablespoons equal 3 cups. Let's make a table for this. Cups, tablespoons. All right? 3 cups, 48 tablespoons. All right? We're going back in the day, a little proportional relationship action. So a good thing to do here would be divide and find your constant of proportionality, right? Dividing, calculating, 16. So my constant of proportionality is times 16 to get from cups to tablespoons. So we could put a couple more in here. 1 is to 16. 2 is to 32, right? All right. Plot and label some more points that represent the relationship. Well, good thing I did that because I need to plot some more. They already got 48 and 3 on there. Let's put 1 and 16. 1, 12, 14, 16. That bad boy needs to go on there. 2 and 32 up to, and the 32's on this axis. So 32 would be right there. All right. I could plot more, but it said to do 2. Check. Done. All right. Use a straight edge to draw a line that represents this proportional relationship. Let me use my handy dandy straight edge tool, and it's proportional. So I'm going to start at the origin, and I'm going to draw through all the lines to show that it's a straight line through the origin. Holla. And then for which value y is 1 comma y. Well, I've already got that one. When x is 1, which, x is the number of tablespoons, right? When it's 1, it's like way down here. Okay, what is y? Y would be right here. So we got to find out, when x is 1, what is y? This is actually our x in the table. This is our y in the table. So, wow, we got to divide by 16. Well, 1 divided by 16 is 1/16. So C is 1 out of 16. If I've got 1 tablespoon, I've got a 16th of a cup. And that's our constant of proportionality if you're going from left to right. I just set up my table the other way. That's why it seems a little weird. So the constant is 1/16. And we need to write an equation for that to show the relationship between these two things. C for cups. So we're going to put, this is C, and T for tablespoons. Okay. We can multiply C times 16 to get T, right? We can do that. We can do 16 times C to get T. But I think the one that they really want is when you reverse the letters and use the reciprocal, a 16th. If you take the T's and multiply by a 16th or divide by 16, you will get the cups, C. So this is what they're looking like for E. C is a 16th of T. And there we go. Second page done. I probably explained it better in the first video, and I apologize. I'm kind of in a rush, but I'm really ready to go home. So deal with it. If you got more questions, just send me an email or something. See you guys.